Hey grade 6s, we're going to be looking at the exciting world of patterning. There's patterns all around us, and whether you find them in snowflakes or you find them throughout nature, there's all kinds of patterns. Everywhere you look, you're going to see them. But we're going to be talking about some mathematical problems. And in fact, you were given several problems over the last few days that had to deal with patterning. And what we ended with was I was asking the question, what operation is most crucial, most important in solving patterns? And half of you voted for addition and half of you voted for multiplication, and certainly there was no one that voted for division or subtraction, so obviously they must be out. But let's go through this and we'll discover which operation it is. So the first thing we have to talk about is some patterning vocabulary. And the first couple you've seen before. The first one is called a growing pattern. Another term for is ascending pattern. Ascending meaning going like upstairs. I'm ascending the stairs, I'm going up. And this pattern is in fact going up. 2, 5, 8, 11, 14. Can you figure out what it's going up by? Stop the video if you need to figure it out. If you said it's going up by 3s, you're right. 2 plus 3 equals 5, 5 plus 3 equals 8, 8 plus 3 is 11. So this is a growing pattern, probably the most common. Another one is really the opposite of it. It's a shrinking pattern. Everything's becoming smaller. And so this pattern here, we go from 98 to 78 to 58, 38, 18. You can see how it's getting smaller. It's descending, like you're descending the stairs, it's getting smaller. So a shrinking pattern. And can you figure out what it is there? From 98 to 78, 78 to 58, etc., etc. So see if you can figure that one out. The next one is one also that you've dealt with before, a repeating pattern. So it goes from, say, 4, 2, 3, 4, 2, 3, 4, 2, 3. Sounds like I'm doing aesthetics or something. Anyway, so 4, 2, 3, 4, 2, 3, 4, 2, 3. It sounds like I'm doing aerobics or something. Anyway, that is a repeating pattern, and obviously you know what it's doing. And there's no trick to it. There's nothing that you have to subtract or multiply or divide or add to figure out. It's just the repeated pattern. And the last one is a new term to you, and it's called a recursive pattern. And recursive basically means that it depends on the one before it. So when you've got a pattern like 2, 5, 14, 41, 122, 365, this is a much more difficult problem. And in fact, it depends on two operations. The operations are times 3 minus 1. So if we do that, we've got 2 times 3 is 6, minus 1 gives us 5. 5 times 3 is 15, minus 1 gives us 14. 14 times 3 is 42. 42 minus 1 is 41. And so on and so forth. But the thing is, if I asked you, well, what is the 5th digit, or what is the 5th number in the pattern, you couldn't tell me unless you knew what the 4th was, because you wouldn't know what to multiply by 3 and subtract 1. So a recursive pattern depends on the number before. Let's see how this applies in some of our patterns. The first thing we're going to look at, or the first type of pattern, is making patterns from rules. And this is very important. It starts with 3. So easy. But this is where most grade 6s make their problems. They forget to start with 3, and yet that's the first 3 words. So you have to start with 3. And if I reveal the pattern, there it is. I put the 3 down. Then we use the rest of the solution. Double each term and add 1 to get the next term. So double each term. So 3 is doubled. 3 times 2 is 6. And then it says add 1, 7. So the next number is going to be 7. Okay? Then we keep doing that. Double the 7. We get 14. Add 1, 15. 15 doubled. gives you 30. Add 1, 31. I want you to figure out the next two. Go ahead, stop the video, and figure out what the next two in this pattern should be. Welcome back. If you got 63 and 127, very good. Give yourselves a hand and a thumbs up. This is another problem that we'll do. Start with 5. So before you go any farther, let's get that 5 down. There you go. Now it says multiply by 3 and subtract 2 to get each of the next terms. So we start with that 5, multiply by 3, so that gives us 15, subtract 2, 13. And that is indeed the number that we end up with. Now we do the same thing again. What's 13 times 3? 39. 39 subtract 2 gives us 37. And you can keep going. And I want to know what would be the next couple of digits in this pattern. So stop the video and figure it out. Times 3, subtract 2. Stop. Welcome back. Did you get 109, 325, and 973? If you did, thumbs up. Good job. This is the next pattern, and this is one pattern that we've dealt with over the last few days. Very similar patterns. So stage 1, you've got 1 block. Then we add 2 more to the top, 1 more to the side, so we've got a total of 4. We've got stage 3, add 2 more to the top, 1 to the side, total of 7 blocks. Stage 4, 2 more to the top, 1 to the side, total of 10 blocks. Well, to figure out the pattern here, it's very helpful to put the numbers in a table. And so here's the table that we're going to use. We've got stage 1, 1 block, stage 2, 4 blocks, stage 3, 7 blocks, stage 4, 10 blocks. Well, now how do we figure out, just using the numbers, how many blocks will be in stage 5? Well, this is where we come to that crucial question that I left you with. What is the most useful operation to use when figuring out the patterns? Could you add them? Would 1 plus 5 give you anything? I don't think so. Would 1 times 4 give you anything? No. What about 4 divided by 1? No. The crucial operation is subtraction. Subtraction is what you need to do. And here we go. The first one, we'll take the 4 blocks and we subtract the 1. And what does that give us? But 3. Now we go on to the next step. 7 blocks minus the 4 blocks. What do we get? 3. Next step. 10 blocks minus the 7 blocks. There's 3 again. Obviously, our answer is 3. And if we look under the title here, yes, we've got plus 3. So then to solve the rest of these, all we have to do is add 3 to each of the previous numbers. So here we go, 10 plus 3 gives us 13. What is the next one? 16. What is the next one? 16 plus 3, 19. And finally, the last spot, 22. So the whole pattern is adding 3 to each of them, and we discovered it by finding the difference between each set of patterns. And the difference is another term for using subtraction. Let's go on to the next question. Here we've got the stage of the problem, so we're going up to 7 this time, and we've got the number of blocks. So in the first section we've got 6 blocks, then we go up to 16, 46, and 136. What operation did I said that we should use to solve these? Subtraction, right. So we take 16 and we subtract 6. And when you do that, you find out it's 10. So that's our first difference, the difference between these two numbers. What's the difference between the next two, 46 and 16? Oh, you get 30. And the difference between the next two, 136 minus 46, gives you 90. Wow. It's certainly not as easy as 3, 3, 3. But there is a clue here. what do these numbers have in common, and how do you get from this stage up to this stage? What can you do to 10 to get to 30? Multiply by 3. Well, how would you go from 30 to 90? Multiply by 3. So because they're both multiplied by 3, then we know that times 3 is one of the things we need to do to switch out blocks. And if I lift this first block, times 3 is the answer. So 6 times 3, if we go back to the original question, is 18. How would you go from 18 to 16? Well, you'd have to subtract 2. Well, let's see if that rings true for the next step. 16 times 3 gives you 48. 48 minus 2 is 46. 46 times 3, 138. 138 minus 2, 136. So yes, indeed, we have figured it out that not only do we have to multiply each number by 3, but then we have to subtract 2 from each of these to get the next step in our pattern. And sometimes they refer to these things as an input-output machine, whereas you take 6 on the input, so 6 times 3 minus 2 gives us the output of 16. If you did the next stage, 16 times 3 minus 2 gives you 46. So sometimes you'll refer to that. But most importantly, we have to be able to go on and solve this next problem. So we use our input-output here in order to find what the answer is. So 136 is our input, 136 times 3, then minus 2. And we find the answer is 406. So we can write that 406 as our answer. How do we find the next one? Same way, you take 406 times 3 minus 2, and we find the answer is 1,216. And so you write that in the answer, 1,216. And finally, the last thing, 1,216 times 3 minus 2 gives us our final answer of 3,646. So sometimes patterns can get pretty complicated, especially when they involve two operations. Look for patterns all around, and I look forward to working with you in class. Enjoy.